Okay, let me walk you through the notes for this week. First thing to do is to run the command to make the tidyverse available to your R session. This is always the first thing we do. So pause the video and do that, then come back, restart the video. Okay, you're back. Here's the command, library tidyverse. Very simple. So in Moodle, there's a data set, OAW2309.R data from Moodle. Load it and then use Glimpse to inspect it. So pause the video and take care of that, then come back and we'll look. Okay, you're back. So here's the load command and the glimpse, and we see what we've got is daily weather records from the Olympia Airport, beginning with May 13th, 1941. And the values, the variables that I've got are precipitation, maximum temperature, minimum temperature, and then we have separately the month, the day, and the year. Okay. So the next task is to use filter to create a data frame with just the observations from January 1st. Call this new data frame January 1, and then use head to verify the result. So pause the video, perform the task, and then start the video again. Okay, you're back. So this is a filter. So January 1st is OAW2309, and then filter. Month equal 1 and day equal 1. And here we see that we've got all the January 1st. Here's 1942, 43, 44, and so on. Task 4. Warming, that's a good question. Use this data, that is the January 1st data frame, to consider the possibility that weather in Olympia has been getting warmer. Create an appropriate graph using the variables YR and Tmax. So again, pause the video, perform the task, then restart the video. Okay, you're back. So we start with January 1st, Jan 1, and then ggplot, and the aesthetics puts year on the x-axis and Tmax on the y-axis. And we do a geom underscore point and a geom underscore smooth, both of them. And no, I can't see that there's any real indication of warming here. Well, maybe there was some warming in this period right here, but then we're kind of, at the end, we're kind of back down to where we started. Okay. Next task, create a new data frame, JFM15. It contain data for the 15th of January, February, and March, and then use head to verify. And stop the video, perform the task, then restart the video. Okay, you're back. So JM15 is OAW2309, and then filter. Month is in the vector 1, 2, 3, and day is equal to 15. And then we look at the head, and we see 1942, January, February, March, 1943, January, February, and March, and always the 15th. Okay. Compare the values of Tmax for these 3 days with a box plot. And here I forgot to delay, but that's pretty easy. ggplot, AES, X is MO, Y is Tmax. Then GM underscore box plot, and GG title Tmax values. And you can see that as we progress from January to February to March, that we get a little bit warmer. The medium temperature is probably about 46 in January. Looks like about 49 in February. And then up well above 50 in March. So here's a different comparison. I want to use faceting to show the difference among those 3 months and make the basic plot a histogram. Again, stop the video, perform the task, then come back and look at my solution. Okay, here we go. For a histogram, you just have one variable. So we put Tmax on the x-axis, GM underscore histogram, and GG title, Tmax values, facet underscore wrap, tilde MO. And here we get the 3 histograms. And you can see if you look very closely that as we move from January to February to March, the temperatures get a little bit warmer. The next task, repeat the previous exercise but use GM underscore density instead of GM underscore histogram. Pause the video, perform the task, then come back and look at my solution. Okay, you're back. Same code as last time, except that instead of GM underscore density, you have, instead of GM underscore density histogram, you have GM underscore density. And the must look a little bit different. You can see that in January, you have sort of a flat peak with probably about 44 being the highest value, and it sort of tapers down, but not very much, towards 50. In February, you have a very sharp spike, and the spike is right on 50. And in March, it's not quite as sharp a spike, and it's a little bit to the right of 50. Okay, task 9, use mutate to create a new variable, tdiff, in the OAW2309 data frame, and you calculate it as Tmax minus Tmin, and then use head to verify your work. So again, stop the video, perform the task, and come back and look at my answer. Okay, you're back. So OAW2309 is equal to OAW2309, and then mutate. Tdiff is Tmax minus Tmin. And here you can see the first few observations. And you've got Tdiffs of 16, 16, 14, 10, 11, and 20. Okay. So create a new data frame, sum, which means summary underscore diff, with one row for each of the 12 months. The new variables in this data frame are mean underscore diff and SD underscore diff, and arrange the data frame by mean underscore diff. And this exercise should take you a few minutes. So again, stop the video, perform the task, then come back when you're done. Okay. So this thing uses group by and summarize. You group by MO, then summarize. Mean underscore diff is the mean of Tdiff, and SD underscore diff is the standard deviation of Tdiff. And then we arrange by mean underscore diff. And it looks like the lowest difference is December, second lowest difference is January, and the third lowest difference is November. So it looks like the cold months have smaller values of difference. Task 11, create a scatter plot of mean underscore diff and SD underscore diff. So stop the video, perform the task, then come back and look at my solution. Okay. So again, we do a ggplot with mean underscore diff on the horizontal axis and SD underscore diff on the vertical axis. And we can see that as mean underscore diff gets bigger, that the standard deviation gets bigger. So I want to create a scatter plot of mean underscore diff and MO. So stop the video, perform the task, and come back and look at the results. Okay, you're back. So I can see that the big differences are during the warm months of the year. These are July and August. And it looks like the higher the Tmax, that's what you're really seeing in the months, the greater the average difference. Yeah. And that is the end of today's presentation.